This is the demonstration video for AAMAS-26 submission on orchestration. The current orchestration platforms follow a very simple pattern. They're all LLM based, implicit orchestration through prompt engineering, or at most have reasoning enhanced LLMs. At the end of the day, LLMs for all would lead to inaccurate and heavy compute workflows. The solution is to support semantically aware heterogeneous agent management. We achieve this through a process called knowledge infusion, where semantic information decision making would lead to domain knowledge grounded expertise. This increases robustness, which is ideal for orchestration and task decomposition. KiMO is a two-brain orchestration framework with PlanGen and AgentGen. PlanGen takes in plan ontologies and AgentGen takes in agent registry as the two knowledge sources. The process starts with task description and asset metadata provided to PlanGen, which then performs subtask decomposition or dividing the task into solvable subchunks using the ontologies, and sends individual subtasks to AgentGen. AgentGen generates workflows iteratively for each subtask through a three-stage process. Constraint-based filtering filters out the necessary agents. GNN-based scoring adds in suitability scores. And beam search finalizes the input-output streams and the edge connectivity to finally lead to verified workflow for a subtask. This subtask is then consolidated and displayed in the front-end interface. Stage 1 consists of PlanGen, which is a raft fine-tuned Llama 3 billion parameter model on planning ontologies, while the AgentGen is a GNN trained on agent registries. In our demonstration, you will be looking at complex task submission through the manufacturing example, semantic decomposition achieved through PlanGen, intelligent agent selection through AgentGen, experts customization options available through the workboard. On the left is the flowchart of how an example goes from the start of task description and input sources provided all the way to the end, where a finalized workflow is generated for the manufacturing example. Now let's check out the user interface. Upon launching the interface, this is the first page we see. That is PlanGen. PlanGen takes an input of task description along with metadata of data assets, and custom plan templates can also be seen on the side, which is from the prior ontologies. Users also have an option of entering manual workflows if they feel they already have a workflow which is sufficient enough, rather than going through the process of PlanGen and skipping the process directly towards AgentGen. But for this example, we are going to stick with task description given for the manufacturing example and metadata of the data assets uploaded to generate a plan. This takes about 3 minutes. After the execution of PlanGen and AgentGen, we enter whiteboard. This whiteboard provides users or experts with ability to intervene in either plan level or agent level with their modifications. On the left side, we see blocks where users can drag in their custom plan blocks, and for the current manufacturing pipeline, we do see the output of anomaly prediction, manuals guide, and conversational chatbot to be the output of the PlanGen through the subtask decomposition. And upon clicking on each of the subtasks, this is the anomaly predictor agent which has been created for the anomaly prediction subtask. It takes in two inputs, CNN and LSTM, leading to create the anomaly predictor agent with the facility or the capability of multimodal anomaly detection, anomaly classification, and real-time inference. Agent takes in sensor data as input and gives out an anomaly report. On going back, similarly for the manuals guide, targeted to have retrieval and mitigation guidance as its capability, And if sometimes these tools are not sufficient enough, there is a tool registry on the side through which we can pull in additional tools. Finally, the conversational chatbot is the main workhorse for this platform and has user query as the input with the final answer as output, anomaly report, which is the output from anomaly prediction agent, and mitigation steps, which is the output from the manuals agent as the input streams, which also showcases the dependency. To download the workflow, export, and run the bash commands in their own local systems. In case the agents provided are not sufficient enough, there is a provision to create own custom agents. Users can create their own agents using the tools and available assets by defining in the following format. And upon clicking generate agents, custom agents would be created on the side. This is all for the system. Thank you.